Hello. I had a plan of what to do for this stream, and then I got a problem report on the Axminster app. Yesterday, I posted a demo of Axminster. It's a UML and OCL modeling tool that has support for MCP servers, so that you, as a software engineer, can use your coding assistant, your LLM-based tool, to work on a software model. The idea is that this should allow an easier approach to like validating what the LLM is doing than just reading like markdown files of specifications, because it's a visual tool, and also it's a tool that has a particular, what the OMG call a meta model. It basically has its own semantics, so we can make sure that the software model is internally consistent, which you can't do with a markdown file. It's just a collection of text, and like we have spent the however long it is that the software industry has existed, 70, 80 years, understanding that plain text descriptions of software aren't a good and precise specification language. Now, this problem report came from a member of the Patreon, Brandon, who I've been working with on creating the app icon, which is the one thing that remains before we get the app into test flight. Now he wants to use the app to find out what the how to use it, and like what its capabilities are, so that he can understand more about it, and like use that information to help design the icon. As you can see, I've got Claude working on fixing a problem. Now, the problem that he reported was that if you create a model using the MCP server, you can't actually save it, and that is due to the way that the app sandbox works. This is a sandboxed app on macOS, which is a prerequisite for getting the app onto the App Store. And if you create a model in the MCP server, you don't go through any explicit UI actions that tell the app that you want to use a particular document file. Therefore, the app doesn't have access to the location that you want to save the document URL file to, and so saving fails. So what I did was, actually it happens that I wrote the Apple documentation on how to work with files in the app sandbox, so I know this area of technology pretty well. So I came up with a collection of 4 constraints, which we'll look at the beginning of this interaction, and I make the point that the app can only access read and write files that have been permitted through explicit GUI actions. Those include using the standard open panel, standard save panel, dragging a file onto the app icon in the dock, or double clicking an icon in Finder that is explicitly associated with the app through a role definition. And then I come up with 4 constraints that the app needs to honor for the interaction with between the MCP server and the GUI to work correctly. They are that if you create a model through the MCP client, the app needs to open the model in the GUI. Now, because the Axminster app keeps the GUI state and the MCP server state in sync. In fact, it uses a shared state and a command pattern to update that state either through GUI interactions or through MCP tool uses. If the model is open in the GUI and the MCP server is making changes, those changes are reflected in the version that you see in the GUI. So when you explicitly save that model using the Command S save action or file save menu item, all of the MCP's changes, i.e. all of the LLM's changes, will get included in the document that you save. So this first constraint is a necessary prerequisite for turning a new model that the LLM creates into a document that the developer and the LLM can both work on. Second constraint, the open model tool only permits opening files that the app already has access to. So if you pass an arbitrary path, that should fail because the app isn't going to be able to open it due to the sandboxing constraints. The way that the app works is that when you do open a file using the open panel or dragging the icon onto the dock or whatever, in addition to opening that file as a document, the app also creates what's called a security scoped bookmark, which is opaque data that the app can pass to the operating system and say, I've got supplied permission, pre-authorized permission to access this file, extend my sandbox to include access to it, and give me a URL to the file. So any model file that you have ever opened in Axminster, you can open directly through the MCP server. But any file that you have never opened, you can't. So there is this constraint that you need to get an error if you try to open a file that you just downloaded or been sent an email or Slack or whatever. Third constraint, in the situation where the model was created by create model, the save model tool needs to report an error to the client that says that it can't save, the user needs to do it. Now, in actual fact, the save operation, if you have opened a model file explicitly, is a no-op because the application uses autosave. Because it's using the command pattern to make updates, it's got an undo manager and it's got a list of unsaved changes, and so periodically it can write those changes out. And even if you do overwrite a file with a save, because you've got the undo manager, you can still go back to earlier revisions from before the save action occurred. So saving is a no-op in the MCP server for a model that comes from a file that you opened. In the create case, the MCP server cannot save the file. You need to tell the user, tell the developer, it's your job to save this explicitly in the GUI. That's by design. That is to live within the app sandbox constraints. And the fourth app constraint is that you can't save as. You can't specify a file in the save operation and say, write the file over here, because that isn't going to work. It can only work if it's overwriting a file that the app has previously used. So these four constraints together represent the predicates that need to be satisfied for the app to be a good citizen of the app sandbox model. I then use the guided navigation pattern from the interaction patterns catalog to tell the LLM where the relevant parts of the application logic are. Here's the MCP server definition. Here's the thing that manages the bookmarks and the document sessions. And here is the thing that absorbs commands and uses them to update the model. And then it turned out I hadn't logged into Claude. And we find that 3 of these 4 constraints weren't satisfied. creating a new model wasn't opening it in the GUI. That meant that there was no way for the user to go through this like shadow operation. This saving operation. It was kind of maintaining a shadow document that the GUI didn't have any access to. Therefore, it was impossible to extend the app's sandbox to permit it to save the model that was created. That's a problem. That's actually the problem that Brandon discovered and reported. Open model only works if you've already got access to the file, and it uses the security scopes bookmark that already existed because that was the situation I thought of before. The save model was just returning the path that it saved in the case of success and a generic error in the case of error. So this was always trying to write directly to the file, which would fail for new models and not do anything for existing models. And finally, there is an optional path argument to the save action. Therefore, that constraint was not satisfied. The MCP server looks like it gives LLMs the capability to write model files wherever they want. In practice, not true because the app sandbox forbids it. So we restrict this to only being a save action, which, as I say, in the case of a document that's open in the GUI, does nothing, and in the case of a document that's open in the just through the create model command, throws an error. So we could ask, do we want save model at all? I'm leaving it as a tool because I think that probably I'll want to do checkpointing, kind of explicit save checkpoints when I start to do document round trips. I start to do file generation, source file generation, and updating models from source files. Parsing a source file will cause like a string of commands, 0 to many, to be sent to the model at once, and it seems like that would want to be a transaction, and so therefore, like having save model as a kind of transaction barrier, if you like, would be a useful thing. So that's the reason I haven't removed that. So then I asked, this is actually like Claude Opus, to create a plan using the create execution plan skill, which is in the Chiron Codex agent skills repo, to like ensure that those constraints are verified. And actually, it then loaded a bunch of the other skills. So ambiguity resolution is a skill that implements the disclose ambiguity pattern. Design verification strategy is a skill that implements the trust the tests pattern. So as well as coming up with a plan for like changing the code, Opus has come up with a plan that includes asking me what to do about gaps in the plan, a common problem with vibe coding, and it's come up with a need to have solid tests based on my description of what good tests look like. So it's come up with a few like questions. How should the tool open a GUI model? And I told it just to use the SwiftUI new document command as a callback, so that it's literally doing the same thing as if the developer used like file new in the app. I told it to report an error from the tool if you try to save something that the user needs to save in the GUI, but to put the message that that's what happens in, so that the LLM sees that and replays that to the developer. And it's noticed that the save model doesn't do anything. It relies on autosave, and asked whether we want to fix this. And I've said no. And then should the MCP server ensure that the window is actually open before it returns? And I've said yes here, just to avoid a problem where we start to get changes to the model through the MCP server before the app is ready to reflect them in the UI. So now it's got the detailed plan. We've seen these in previous cases where I've used the create execution plan skill. So I tell it to create a risk matrix and its plans for mitigation. It's created a verification strategy. It includes unit tests and smoke tests and a definition of done. And then it's come up with this roadmap. Now, I knew that this approach would work because I know how, I know enough about how SwiftUI works. I'm far from a SwiftUI expert, but I know enough about how this new document mechanism works to be confident of that. So I told it not to spike that and just to proceed to implementation. And then there is an agent's MD in here that says to create beads issues for every task and then get me to review them. And I just said, don't worry about that because this is a fairly small collection of tasks. Let's just get on with it. Bunch of changes. And we've got to the point where it's actually worked, or rather that creating a model opens empty windows in the UI. So it's going on to validate the other constraints. It's trying the things out that shouldn't work and checking whether they do work or not. And this is effectively the app, the Claude Opus model smoke testing the app by manually driving it. It's actually using Apple script to drive the app and then taking screenshots. So I was kind of hoping to have this finished and out of the way before I started this stream, but it is an interesting thing. We've seen a bunch of patterns. We've seen stop and plan, which I always use. We've seen guided navigation, which just helps to kind of focus the model on the relevant code, the LLM model that is. We've seen truster tests. In fact, we're watching truster tests now, not relying on the model saying, okay, everything's 100% production ready. Disclose ambiguity, which the LLM automatically chose to use. It discovered that skill and loaded it and used it. So that's 4 patterns. And as I've made the point before, Axminster is itself a Chiron Codex interaction pattern. It is replace vibes with tools. We've got a thing that we can do with a deterministic process, that is construct semantically valid models of software and explore those models both as human software engineers and as LLMs getting input for generating code. We're choosing to use that deterministic tool for that part of the process rather than a generative tool, so that we get more reliable outcomes. I'm just going to open my window a second. We're in the middle of the 5th heat wave of the summer here in the UK. Temperatures are already above 30 degrees Celsius. I need a little bit of a breeze. You may hear the door start to rattle now that there is a cross breeze. So I'm going to use Axminster. Once we've finished this and we've reviewed the code changes that Opus has generated, I'm going to use Axminster and I'm going to use this MCP server because the actual feature I want to get onto is, and you can see that a change that the LLM made in the software model got reflected live in the GUI. Sorry, the feature that I want to work on now, once we've finished this bug fix, is in my on the wing digital nature journal app. Currently, it allows you to record observations, including attaching photos, save those observations in a journal, write reflections on your observations. You're limited to a small number of photo uploads. And the idea is that that's the free tier. The paid tier doesn't have limits, but you pay a monthly or annual subscription to remove those limits, which offsets the cost of running the service and paying for the storage for the photos. So I want to do payment integration. I have not worked on that before. I've mostly worked on kind of Unix services which are completely UI-less, desktop apps and mobile apps that have that use kind of the App Store or other fulfillment mechanism. Like you have already paid for it by the time you get the app, and a bunch of web apps that are either free or where I wasn't on the payment flow. So this is a new piece of work to me, and I know it's a solved problem. That there are tons and tons of software as a service products out there. So I'm confident that there'll be a bunch of training data on how that stuff works, but I still want to get it right. I still want to be quite careful about how the payment path in this app works. So what I'm going to do is carefully model it, review my model, make sure that the model is consistent and correct, and then I'll work on the code and implement the code from a consistent model. Now this, it sounds like I'm saying, right, I want to follow a plan rather than responding to change. There's no change involved here. The kind of change points are: does a customer want to pay at all? How much do they want to pay? How do they want to pay? And what do they want to get for their money? This initial implementation of the payment feature is going to take a guess at those that I'll then validate in the market. So all I'm doing is saying, right, for this payment spike, if you like, this kind of payment validation experiment, I want to be sure that everything works properly. I want to make sure that people who are charged actually get the thing that they want, that people who don't want the thing don't get charged, that they can back out. You can go from being a subscribing member to not being a subscribing member, and that you stop getting paid, you stop getting charged at that point. That if there are refunds, those are processed correctly. Just the things that are basically treating the customer with a level of respect for trying to take their money. So yes, there will be a detailed plan in this. That is entirely expected. So we're going through the thing where it's trying to explicitly save the file. So to like validate that part of the workflow. Hi Stephen, good to see you. How you doing? You tell me how you're doing. I'm going to go and get a glass of water. It's really hot in here. Good, nice deterministic mute button there. At least it's not. Well, it was showing evidence of being an idempotent mute button, which really isn't what you want. So it's decided that it can't uh, do that test, which is basically the once you have saved a model, you can then save the model. I believe that works because I've seen it work before. Like, that is the existing code path. That we could do a quick test. Run the app. New chat, which we're using we use open code for. This will be slow, but whatever. So what we're going to do is create a model in using the MCP server. And I know I always use the use cases in my demos. We'll move on to more concrete demo when we move on to the on the wing thing. So Stephen asks, what's the current task? Just before I went live, or rather actually overnight, but I read it just before we went live. Brandon reported he had a problem where he'd used the MCP server in Axminster to create a model and then got an error saving it. Now that is expected because the app is a sandboxed app. It can only open and save files using explicit GUI commands. But the MCP server needs to have a bunch of constraints on the things that it allows the model to do to ensure that it never gives the impression that you can do something that's outside the app sandbox model. So I came up with a list of 4 constraints, which have now popped off the top of my scroll history. So if I resume the session with Claude, I can just scroll back through its log. Oh, apparently I can't because it's just paste the text. Okay, I came up with a list of 4 constraints that are if you create a model using the MCP server, then the app has to also open that model in a GUI window so that the user has the ability to like save it explicitly using the file save menu. If the MCP tool tries to open a model, it can only succeed if it's a model that Axminster has previously opened. And that's because it's got security scopes bookmarks for any document that it's previously visited, and it doesn't have access to any other document. If you try and save a file that you have previously created through the MCP server, that needs to fail, and the error message that the MCP server responds with needs to say you have to use file save in the GUI to save this model. And the 4th constraint was there's no save as in the MCP server. You can't specify the path to a new model. Sorry, you can't specify the path to which to save a model because you don't necessarily have the permission to write to that path. You can only save models to the document that you open them from. And basically, Claude had nearly finished working on that when I went live. I thought, okay, let's just kind of wrap that up because my implementation of that showed stop and plan, guided navigation, trust the tests, and it shows a bit more kind of use of Axminster, which is always good. And actually, we're 32 minutes in, and I'm still like validating the last behavior. So there are the use cases that it's come up with. I didn't ask it to like kind of create the system boundary or the actors. So the idea is I should now be able to save that file, which I can, and there is my file on the desktop. And then, assuming that this integration with the MCP tool works, the MCP server should now be able to like make a change and use the save command and not get an error. So that's my test. Let's just bring Axminster back up. And so while it's doing that, and before we review the code changes that that Claude made there, my actual task today, once we've got through this, is I want to add Stripe payments for subscription billing to On the Wing, the digital nature journal app. Now that I want to be very careful of because like, I'm using web objects for the app, so there isn't any existing Stripe implementation. I'm just going to be using the web API and the webhooks. So I want to make sure I get that right. And I want to make sure that I cover all of the like use cases correctly, so that people get billed correctly, they can cancel their subscriptions, they don't get charged when they don't need to get charged. All the basic stuff that, like, if I was using like kind of TypeScript or something, then there would be a module that got all that stuff right. If I was using Rails, there would be a gem for doing like subscription payment that would just like I would just add that and it would get all of those things right. I want to be quite careful about planning this to make sure that I do all of those workflows correctly. So we're actually going to use MCP, Axminster, and a Clanker to build a model of this thing and validate that model is correct before we like try and write payment code and take a load of money from people for things they don't want. Okay, so it did indeed add the system boundary, add the actor, and save the model, and it didn't get an error saving the model. That's all good. Saving the model in where it actually doesn't do anything because the document is open in the app, so it uses autosave. So it still says edited there, but actually if I close the model, it doesn't complain because it's auto-saved it. So it saves an error if you are working on a new model. It's a no-op if you're working on an existing model. I'm leaving the tool in place though, because at some point I'm going to do model round trips where you generate source code from the model, and if you edit the source code you can update the model. Well, that's going to generate a ton of different changes, so it'll be useful to have save model available as a transaction point for like bunching those changes together, I think. So I'm not quite confident in removing it. Anyway, that worked. So that is every test now complete and passing. So we want to look at the source and review what's happening. So now the document registry has a connection to the window opener, which means that when you ask to create a new document, you get a window for it. And we capture the new document action in the environment and pass it into this window opener object so that it can do that. Here is the bridge. So this is the thing that does the action. And opens a window, and this session, this is a model session. So the way that the Axminster app models the UML model, sorry, this gets very meta very quickly. The way that it kind of manages changes to a document is that the MCP server and the GUI both have access to this session, and what they both do is they generate commands that they send to the session. So every tool used in the MCP server is a single command, and every action in the GUI is a single command. And the session maintains an undo manager, and the undo manager applies the changes to the model. That means that we have full undo redo, including across saves, and it means that changes from the MCP server and the GUI both enter the same stream of commands, which means that changes in the MCP server get reflected in the GUI, changes in the GUI get reflected in responses to MCP tools, that the document dirty logic is the same independent of which route the command comes from. It's the command pattern, it's in the Gang of Four books, we've been doing this for like 30 years, but it really, really helps. So we've got this session which lets us track whether we opened a file from the GUI or whether we created a model, because there isn't a session. If or rather, like, because we've got the session, we can use the same session in both places. And rather than saying, like, the way you save this is you pass a path in, you're not allowed to do that anymore. You have to save it in the app. And then when we create a model, we open the window and we pass the session in so that the GUI and the MCP server have the same model. You can no longer specify this URL. Once again, updating the documentation for the tools, and this has turned into an async call on the main thread, because we're now doing a UI operation. We're creating a new window through this this command. Okay, so there's basically, like, there's nothing surprising in here. It has followed the existing command pattern. It's got a bunch of tests that are all calling the tools, and including end-to-end tests that are actually like going through full like round trips and ensuring that, like, errors fail. This is because of my design validation strategy skill. It actually knows not just to create happy path tests, which is something that you often get when a clanker is asked to generate tests because of the completion bias. Okay, well, I'm happy with all of that. So that was the U review pattern. I'm just going to stage all of the changes. Actually, that is the I've just said the same thing twice in two different ways, so I'm going to make that consistent. And then this has got Xcode Cloud, so this will do a build and test in the cloud once it pushes. Right, so actually, like, that's 45 minutes in. That was distraction. What we want is to use Axminster. I've already got a very limited model for on the wing. I'm going to do this. I have a bunch of skills for working with UML based software models, and I'm going to go through this thing in a very kind of deliberate way and build up this model using the AI tool. launch one. So does MCP? Yeah, so anti-gravity has access to the Axminster tool. Let's just use that for this purpose. The first thing I'm going to do is actually work out what the use cases are for this subscription thing. So I'm going to try and write, and I was hoping I would get a chance to do this before we went live, but I'm going to type it in front of you. I'm going to write the specification and get the model to A, work out whether it's ambiguous or not, and B, actually generate use cases that we can use as a basis for this UML thing. Like I say, this is payment. This is the app going from Graham is dicking about with some web objects on the internet to Graham is trying to take money from people. So I do want to kind of get this this implementation solid. So, and we're going to take a very 1990s approach to it. So I have a use case analyzer skill. All of my UML skills previously used plant UML and just got the model to generate plant UML diagrams. Those weren't necessarily semantically consistent, and actually the models weren't necessarily very good, even at generating syntactically consistent files. So they would often you couldn't generate a diagram from them. Well, Axminster works only allows semantically valid changes. So all of the tools that the Clanker has access to, all of the controls that I have in the GUI require that the model go from a valid state to a valid state. So we're guaranteed to generate a valid model of the software that we want to create. That in itself is to replace vibes with tools pattern. That in itself is a really powerful extension. No, I don't want to say UML. So we're kind of preloading the idea that it should use the disclose ambiguity pattern. Did you forget to only generate syntactically valid and correct output to the prompt? Actually, no, I didn't. In fact, the skills even said you are only done when plant UML generates a valid diagram. That wasn't enough to help. And the reason it wasn't enough to help is that if plant UML detects an error in the diagram format, it reports the error on standard error, and then it generates an image file that has the error in it. So the clankers were just going, oh yeah, I've created a PNG file, that must be good, and not checking the error output. But kind of hilarious. Anyway, the part of my motivation for Axminster was to tighten up that loop. Okay, so what I'm saying is that they subscribe using either a monthly or annual subscription, that the subscription starts from the time the payment is accepted. They can cancel at any time. The subscription ends at the point that their existing payment expires, and that the feature that's unlocked is unlimited photo uploading. So I have looked into choices. This app, let's have a quick look at the source. Um, it uses Firebase for authentication, and therefore for user management, and um, it also uses Firebase storage for photos. So somewhere around here there is a photo storage mover. It uses Google Cloud storage through Firebase, and it uses the Firebase SQL Connect Postgres database as the data store, because it's using Enterprise Objects Framework, which is a SQL library. Rather than use Firebase Cloud Storage, I use Firebase SQL Connect and get a SQL database. What all of that means is that why don't I use Firebase payment processing? Well, Firebase doesn't have payment processing, but Firebase does have an extension that provides Stripe integration. That extension assumes that you use Firebase Cloud Storage to manage your user objects, entities in your database, which I don't. So I have to implement a payment provider myself, from almost from raw keycaps, from robotically constructed keycaps in this case. I have to just use the payment provider's API, and I've chosen Stripe because it's quite a commonly used one. It works pretty well. So here's the first step is just list all of the things that people can do. And also write out kind of instructions that explain both to me and to the clanker what it means when people do them. So here we've got there. You already can add observations. It's through a use case called, or rather, it's through a page called Capture. So it's this web objects component. So I will change that one before we move forward, just to keep them in sync, because I think in the model it's called Capture Observation as well. So we'll make sure that is kept in sync. We can subscribe to Premium, and it's correctly identified that there's precondition. You have to be on the free tier to subscribe, and post condition is that you're on the premium tier. Vice versa, you can only cancel if you're on the premium tier, and when you cancelled, you revert to the free tier. And it's got these questions that are ambiguities, and now it's asking me about them. So here we are using the disclose ambiguity pattern. I think it makes sense to only put people back to the free tier, not to make it worse than being free. and I've already got that 50 uploads limit in code as the total number of photos, and you can see that it's updated that. So actually, only 2 new use cases: subscribe and cancel. Like, yeah, those have alternate flows, but there's not as much complexity in this feature as I thought. So now we like keep the model up to date. We should see this happening live because Axminster has change tracking. So we've got payment processor actor. We've got the 2 new use cases. That's now a bit difficult to follow in the GUI, so that's a bug for me for later, is to make that clearer. But you can see that the payment processor is associated with the subscribe to premium. But it isn't associated with cancel premium. So let me use the just ask pattern to find out whether that is expected or not. Right, and it's decided it should be. That sounds logical. Nice. So the next thing that I want to do, I want to ensure that I understand the kind of the workflow involved with these use cases. So I want to ensure that I understand what the observer, who is the user of my app, does, what the payment processor does, how they all communicate through the system. So that's a sequence diagram. and it's got this create sequence diagram like tool in the Axminster MCP server, and it's got a sequence diagram skill that tells it how to use that. So actually we can watch it building this by switching to that diagram. And I mean, this is like, even when I kind of draw box and arrow diagrams on a whiteboard or in freeform or whatever, this is a diagram type that I particularly like because it helps to understand the sequencing of different activities and to understand what's involved at every point. So, like, presenting subscription options, I hadn't thought of. I don't think there are going to be more than one option, but like, I need to think about that now. I need to go through analyzing this use case. Of course, there's the monthly rate and there's the annual rate. So it's absolutely correct that it would present options. I can see that validating the payment and confirming the payment goes out to the payment processor. So that's the point where that's involved. And we've got the cancel, which just goes out to payment processor, gets confirmation, shows it to the user. So that's great. We've got quite a lot of detail here now. Let's carry on using Axminster just to kind of show it off a bit. So the other types of diagrams we can create are class diagrams, state machines, components, and activities. I am going to just generate the class diagrams for these and make sure that it integrates its model with the existing classes in the app. Once I've got that, I'm fairly confident that we will be going towards a working solution. So we'll be able to jump into code at that point. So this is the first point where we're kind of integrating this model with the code. If you're using like a kind of old school software modeling tool, this would be like a round trip feature, which is the kind of thing that you pay the most money for when you use those tools, and it kind of parses all the source. Because we've got a clanker available, we can read the source Uh, I don't. So possibly I missed something in updating my skills that have made it. Uh, they've made it try to use plant UL instead of Axminster here. And go back through my skills definition after the stream. Probably going to run the stream to about midday. So it is 11:07 now. So for like the next nearly an hour. So great. It's now going through this class diagram. We've got the observer. We've got the payment processor. And you can see all of the elements and relationships at a glance here. I'm not entirely sure that this is right. I'm wondering whether this should be filtered to only the diagram canvas that you're currently looking at, or whether it should be sort of structured in a sort of browser view somehow, outline view, so that you can see which ones are relevant to which context. I'd love to have feedback from people on this, but the app isn't quite ready for beta yet, so that's why we're still discovering these issues. Okay, so we've got the observer class, we've got the payment processor class, and the diagrams. Sweet. The last thing I'm going to do is get it to add constraints to the model, so that we've got clear definition of things like you can only use the subscribe to premium method if you are not currently premium. You can only cancel if you are premium. And there is a constrainer for that. So the idea of doing this is that the model encodes without encoding any of the kind of how, without like having any of the implementation details of the product. It has as much logic as possible about what the product does, so that when we convert this into source, we keep all of that logic and then just add these specific instructions. And it's interesting that the LLM has discovered that these elements exist in a global namespace. So this observer and this observer were ambiguous. Now that is possibly a bug. that maybe the MCP tools should be more specific, and you should be able to say add a constraint to this class rather than add a constraint to this element, or it could be the correct way to do it, and you need to have every element it has a distinct name. I think it's more likely that I want to be able to have colliding names, that the class observer represents the actor observer, the class payment processor represents the actor payment processor. They should have the same name. That is what object-oriented modeling is all about. So I do think that that's a bug for later, and I'm going to write this down the old-fashioned way. That's the defer the details pattern in the pattern catalog. Um, I could go in and like fix that bug in Axminster, but then I would like not make any progress on my payment feature. I want to make progress on my payment feature, so I'm just going to like leave that bug aside for the moment. So now let's see the right. So the constraints are that if when you subscribe to premium, you have to not already be a premium member, and afterwards you should be a premium member. And if you cancel, you have to be a premium member. Right, and there is no post condition on that, because you might instantly become a free member if you cancel at the time that your subscription is due for renewal, or you might remain a premium member until that renewal comes up. So I think there is a gap here. I'm going to note this gap now, and then move on to implementation. So we've got I can make a payment, or I can subscribe, and we've got I can stop subscribing, but we haven't got I can remain subscribed. And yes, this is missing. So the payment processor processes a renewal, tells the system which user that was for, everything that I just said. I'm glad I caught that. That's that's the kind of thing that I was like sure I would get wrong in doing payment processing in a web app for the first time, and indeed here we are doing it. Here we are getting it wrong. And so now we've got a new use case. renewal, you have to be subscribed with recurring billing. The payment either succeeds or it fails, and either like the expiry date gets moved or they get told to do something. Awesome. So, and now we're getting the updates to the various diagrams. So again, we can quickly see visually that we're considering this use case in the model. So by telling it to create a plan and to create tasks for the different steps, we're using the baby steps pattern rather than just going, okay, here's like 3 use cases that together implement a feature across multiple objects, because there's no UI in this model, so it's not just the observer and the payment processor, it's all of the UI components as well and the tests. Like, let's take baby steps, let's do it in chunks. This is a feature of anti-gravity that rather than kind of vomiting out pages of text into the transcript or writing out files to your project area, it writes files to a working area and has this this UI for going through and commenting them, commenting on them, approving them, rejecting them, modifying them. So another design pattern from the 1990s. We'll use the facade pattern so that there's an interface that we control between the payment processor and the integration with Stripe. So it's also the create execution plan skill automatically tells it to ask for alternatives, and it's suggesting using the REST API rather than a third-party Stripe SDK. I think that's probably the right thing to do. It's probably the easier thing to do in this context. So I'm just going to agree with that. It knows that it needs to migrate the database schema to add the appropriate properties to the observer. It needs to validate that it's talking to web to Stripe or the payment provider, so that it doesn't get random webhooks that just tell that people have paid when they haven't. We've got unit tests, integration tests, webhook tests. Well, this specific phased plan will change because I've told it we need to do a UI. So now it's going to receive those comments and update its plan accordingly. I want to point out here that, like, I've gone through what a lot of people might consider a relatively pedantic approach to planning. That a lot of people, when told, okay, here's a feature, payments, would open their text editor and start like typing JavaScript into a text editor, and okay, I've created like 3, 4 use case descriptions. I've created diagrams that reflect the use cases, the sequence of activities that occur, including different actors that are involved, the classes and methods that are involved, including constraints on how those methods are used. And all of that has taken me like under an hour. It was because I spent like the first half hour of the stream or more on fixing the Axminster bugs, and then I started on this task. So, this isn't like going back to the days of waterfall. This isn't following a plan over responding to change, because the things that can change in this are whether customers want to pay for this thing, whether how much they want to pay for it, whether they're happy to use Stripe, and whether they're happy with the benefits that they receive in return for payment. And this first approach to billing is one experiment to validate all of that. It's taken me an hour to come up with a detailed plan for doing that. That is like not a huge amount of time. It's made me much more confident that I'm going in the right way. Like, we're not giving up on agile software development here by spending an hour thinking before we start writing any code. If you think that that is incorrect, then please do let me know in the comments. I'm happy with I used to run a consultancy called the Library, which was a portmanteau of laboratory and library, and the argument was that like an hour in the library can save a month in the laboratory, i.e., going straight to implementation can cost you more in the long run than stopping and thinking for a short amount of time. I still like live by that mantra, by that approach to creating software. A little bit of stop and plan, which is one of the patterns in the pattern catalog, can ultimately pay dividends, like orders of magnitude beyond diving in and writing the code. So now I'm quite happy to let the Clanker go on and implement all of this stuff. And I have edited the default agents.md file that Beads creates to say it isn't allowed to commit and push when it's finished a task. It actually has to stop and get my approval. different people have different kind of like risk thermostats here. I kind of think that this is an important thing still, that I am still writing the software and I am releasing the product. I am asking people to give me money in return for using this thing. Like, I want to know how it works. um, Personal choice. So not much is going to change in the model now. Um, we should start to see more changes happening here. So we've also got, it has created this class diagram in plant UML that we don't want. So I'm going to delete that. An EO model D is a kind of declarative description of a SQL schema. It's for people who have used core data. This EO model, enterprise object model, is the same as a managed object model. It is a description that of both the tables and columns in the database and of the objects and attributes in the code, and you can derive either of those from this representation, and they will be consistent. So here we see that we've added a nullable is premium field. That's to support existing migrations. You could also migrate by defining that it is non-nullable and that existing objects get the value no or false. A nullable expiry date and a nullable customer ID. It's called it a striped customer ID. I noticed that in the model. I should have corrected that because we've got this facade pattern in place. And so, like, I'm telling it to keep the model and the code in sync here. I was talking earlier about the kind of the old school approach to the like these kind of UML models, the case software tools we had in like the 90s and 2000s. And I worked at a company in 2007 to 2009 that was very deeply embedded in using a product from Sparks called Enterprise Architect. And yes, that thing that took me an hour just now to generate like those multiple diagrams, detailed representations of like the payment workflow would have probably taken a senior engineer a like a good chunk of a day to do in Enterprise Architect. What they would have then been able to do was like generate source files that had all of the properties in. We've got a clanker that can do that. So like this has sped up this existing process. I don't think that that's the end game of AI augmented software engineering. I think that we're going to invent new ways of writing software. But a huge boost we're getting at the moment is widening access to existing ways of writing software that weren't universally adopted. I do way more fuzz testing. I do way more mutation testing um, using like AI augmented tools than I ever did when I wrote code by hand. Um, because like it's it's much lower effort for me to get into that. It means that like I my knowledge of software engineering it is no longer kind of in advance of my capabilities because like they meet the kind of oh well this is what I want to do in the time available. Now in the time available, I can use much more of my software engineering knowledge and apply it to the work that I do and hopefully get better results. So it is already beneficial to apply these tools to improving application of known like software engineering knowledge. I do think that like after and it will take a while. Remember like the first LLM based AI coding system was Ada in 2023. Claude Code came out in 2025, which is arguably the first popular one. So we're kind of, depending on where you are in a hype cycle, 1 to 3 years into using these tools. That's super early. It's going to take us a long time and some ingenious people to find new things that we can do that we couldn't do before. But I do think that we will do that. And so over the coming decades, we will see new approaches to software engineering coming out. Anyway, we've got our first task done, added the properties to the excuse me, added the properties to the observer object, changed the behavior of the remaining photo quota so that it is if you are premium then it's unlimited, and if you are a free member then it is the difference between your the photo limit and your number of photos capped at 0, so that it never goes negative if you drop from premium membership to free membership. And then the changes to the schema to reflect that. So we can commit that. I'm happy with that. And yeah, to be honest, if I if I were doing this by hand, if I were doing this by hand, then like at this point, which is slightly under an hour into starting this task, I would probably be at about the same place myself because I would have like gone off and read like Daring Fireball or Hacker News or something partway through. I would have done a lot of web searching about like how I need to integrate with Stripe. I would have probably like already written more tests than the Clanker has. The Clanker has written 0 tests, but I wouldn't have like got any further in terms of like having more than the customer ID, the subscription date, and the premium status. I just would have had some tests that say that I need those things. Argue amongst yourselves, agilists, whether those things genuinely exist if they've been written in code without working tests to back them up. Okay, so more code has occurred. We've added the payment processor to the make file for both the test target and the app target. The facade is a protocol. Got some decent documentation there. We've got error output, so we accept that communicating with the payment processor can fail. And we accept a secret. At some point, I'll need to go through and generate, create an account on Stripe and generate that secret and add it to the Kubernetes cluster. We're not there yet. And we've got the requests so we add our authorization secret to the headers. We make the requests and set the error if we get an error, and we also do the cancelling subscription. Right, while it's working on this task, I'm just going to go and have a quick break. I'll be back shortly. I'm very aware that this has been a combination of me monologuing at the camera and staring at Clanker's output for most of the session. So, if you have any questions about my workflow, any comments on how I'm working, anything like that, just drop it in the chat and we can actually have a discussion instead of a like slam poetry session. Right, so now we have a new component premium subscription component and integration with the user profile. It seems like a good point to actually test this thing. So I need to make sure that Podman is running. And it won't work because we don't have a local facade. I need to make sure that Minikube is running. So we don't have like the local mock version of the payment facade. So I'll be able to see the payment UI, but I won't be able to like make payments because it will try to use Stripe, and I don't have a Stripe secret deployed in the app. But being able to see it is a good start. Always good to like run the software that you write. Okay, so now I can use scaffold. So what scaffold is going to do is to build the app in Podman, and it fails. So that's good. And what I'm going to do is call out error. So this is where I don't try to diagnose the error. I just tell the clanker what the problem was and get it to diagnose it, because there's a chance that my analysis will be off base, which will lead to attention problems where it's trying to like use my incorrect information to fix the problem. So what I'm doing instead is just saying, here is the problem, and letting it evaluate it. Great. So it was just that it was using the Clang Objective-C syntax, and I build with GCC in the container. So let's see if that now works. Nope. And I know what the cause of this error is, but I'm not going to tell the clanker that. As you would say, Stephen, I don't work here. Oh dear. Now I've got an error connecting to Debian. That's unfortunate. Not entirely sure I can work around that because, well, I suppose no, because even if the so if I find a container file, maybe Stephen can correct me here. But even if I don't try to update, I do still need to install all of these packages. And so if I can't connect to the servers, and I can't install the packages. That's suboptimal. I'll just give it one more go in case it was a transient problem. Yeah, that's better. Great. Lucky. Otherwise, it's a very anticlimactic end to the stream. Okay, we are moving onwards. And now it's deploying everything, so that's good. Just deploying the, just waiting for the app itself to come online. Great. Okay, so it has started. Right, so here is the app UI. I'm running locally, so I don't have any. I don't think I have a test user. Okay, profile. I didn't remember the name. That's a bug. I think it's actually a limitation of the Firebase auth process. I put a name in, it sent it to Firebase, it then asked Firebase, or into the Firebase emulator rather, it then asked the Firebase emulator for my user details, which didn't include the name. Manage premium subscription, I can choose. Okay, it's chosen random numbers. That's fine for the moment. I can subscribe, and it's like pretended that worked. Okay, so what we're not seeing is UI that tells me whether I am a premium subscriber or what my date is, what my renewal date is, or what or how to cancel. So that's all things that need to be added. So, I mean, it's one of the standard things that these LLMs do, that it's kind of created great demoware that doesn't fulfill the brief. Luckily, because we've got this model, um, we know that the actual logic is going to be correct because it's constrained to do what's in the model. But the UI is outside of the software model because the model is technology agnostic, and it's done demoware for the UI. So I'm going to get it to correct those issues. We're coming up towards the end of the stream. Hi, Daniel. Good to see you. Um, so, just to catch you up, I was going to spend 2 hours doing payment processing in On the Wing. I actually had a bug report in Axminster from Brandon, who's working on the app icon for it. So I spent about the first sort of 40 minutes of the stream fixing that bug, and then I've been using Axminster to model Stripe payments in On the Wing because I have never been the person who builds Stripe integration before, and because unsurprisingly WebObjects 4.5 doesn't have a Stripe component available already. So I wanted to build it from. I needed to build it from scratch. I wanted to get it right. So I've been using Axminster to create that model, and now we're implementing it. And the implementation looks good. The it's working through the UI. Well, the implementation is incomplete, but like looks accurate. But the UI was a bit kind of demoware. So that's where we are at the moment. The app is built with in a container and is deployed locally in Scaffold. So once when it when it made those updates, Scaffold detected that and triggered new builds, which are just getting deployed into Minikube right now. So as soon as that as soon as that deployment is finished, we'll be able to go back into the app and see the changed UI. So currently it has this like upgrade to premium view, which is kind of, this was in US dollars and this is a UK centric product. B, these values are hard coded in the UI, and C, you get shown these subscribe buttons even if you are a uh, a member at the premium tier. So like, lots of UI logic problems, even though I'm pretty confident that the implementation logic is going to be sound because I modelled it graphically with the Clanker support using Axminster, and can very easily see what happens in each of the workflows. So this deployment is actually like surprisingly slow, but it's just got to a point where it's realised that it needs to rebuild the app. I imagine that because there were multiple edits, it actually went round that that loop multiple times. So we'll get to the point where the deployment stabilizes, see the new UI in the in the Scaffold deployment. So this is a local deployment running on Minikube on my development workstation. And then I'll probably call the stream there because there's a lot more to do to get payment working. But we've been online for 2 hours now. That's probably enough time for most people aren't going to watch a 2 hour video. Okay, good. So we got to the point where we're rolling out the updated images to the cluster. Again, this step is surprisingly slow. That is the problem with these live streams. You spend get a 2 hour video, and about an hour and 45 of it is me either waiting for a clanker to generate text or waiting for a build to finish. I don't know if if you have any ideas on how to make them more interesting. Short of song and dance numbers, there isn't very much space in this room. I'm all ears. Oh, it really is doing very little, isn't it? So just to review what it was doing while we're waiting for that, it has put the subscription UI into this plist file. I would break this out into currency and amount. I'm not a big fan of having this all in one place because it's still basically doing it for the UI. It's not doing it for the for the app because it's not using the pricing information in the app yet. But we know we need to. It's changed the profile to have these your membership status, your renewal date, and your managed subscription, and then it has a subscription. Make it easier to find by looking at the changes. A subscription component. Again, expiry date, ability to cancel, or upgrade with prices. Once again, it has left the text hard coded in there. That is amusing, but it's probably then fixed the bindings. Yeah, so the buttons, while they have the hard coded dollar amounts, they are their values are actually bound to strings in the code, which will be read from this property list or stuck in hard coded there. So there's a bunch of places where it's still hard coded, but it is ultimately getting the information from the property list file. So go into my profile. I'm on the free tier. Encoding problems. Still need to fix the UI. Let's take a screenshot of that so we can get onto it. Back into my profile. Because this is all simulated, it hasn't actually updated the object, but now we've got a much cleaner UI that should, in theory, show the relevant information. I'll go through, I'll fix those remaining UI bugs, and then I'll move on with the implementation. But I'm going to stop the stream there after a little over 2 hours. Thank you very much to those of you who watched live. Of course, the stream will become available as an on-demand video on Patreon as soon as they've processed the live stream. I will also upload it to the Chiron Codex YouTube channel, so you'll be able to watch it there. And wherever I see you, I will see you soon. Have a good day.